See, we have already studied that pressure exerted by fluid is given by this formula h rho g, where h is the height of fluid, rho is the density, and g is the acceleration due to gravity. Now consider this thing, the air column above my hand is the vertical column of air which is extended till the top of the atmospheric, right, atmospheric layers. So that is also, gases are also considered as fluid. So this vertical column of height, of whatever height this atmosphere extends up to, this height is also extending, or this is also putting up some weight or some pressure on my hand, because force exerted per unit area is called pressure. So this time, what pressure would be, what we call is, if it is exerted by atmosphere. That is what we are studying about, atmospheric pressure. Atmospheric pressure at any point is equal to the height of air column, or you can say, I'll start it with this. We are talking about atmospheric pressure. This is equal to weight of what? Weight of air column per unit area, or of a unit cross sectional area, weight of air column of unit cross sectional area extending from that point to the top of atmospheric layers. So suppose this is the point where we have to find the value of atmospheric pressure. So atmospheric pressure is equal to, we'll draw a unit area above it and we'll extend it up to the top of atmospheric layer, whatever is the top, right, Earth's atmosphere, and that height, in putting that height in this formula, this pressure is called atmospheric pressure. So I'll just repeat it once. Atmospheric pressure at any point is equal to weight of air column of unit cross sectional area extending from that point to the top of atmospheric layer, or to the top of atmosphere. Okay, so if atmospheric pressure is there, there must be some other thing or experiment to find the value of atmospheric pressure. This experiment is known as Torricelli experiment. Torricelli was a scientist. Torricelli's experiment, and this experiment very clearly elaborated how atmospheric pressure exerts and what is its value. What was the theme of experiment was, how it was performed. A beaker filled of, this beaker is completely filled with mercury. Okay, it is taken, and there is a test tube, you can say any tube. This is also filled entirely with mercury, and this tube, see how we are doing this thing. Suppose this is the beaker, this is the tube. I filled it completely with the mercury, closed it up and dipped it inside this mercury tank or mercury beaker and removed the thumb. Now what is the new thing now here? Here the mercury filled tube is like this. Okay, this tube was, at that time was, during the experiment it was taken to be of 1 meter in length. So right now what is happening, initially it was completely filled with mercury, but when the lower opening or lower closure was removed, what happened? The mercury started moving or falling back, falling down, creating a small vacuum inside the tube, right? This will happen. Now this vacuum is called Torricellian vacuum, and important fact is that the vacuum always held the 76 centimeter of mercury, right? From this point to that point, this was 76 centimeter of mercury. Now the thing is, no matter what the position or the way we incline this tube, suppose this tube is not inclined straight vertically upwards, suppose this tube is inclined in this way, even then the vertical height up to which the mercury remains suspended inside the tube was still 76 centimeter only, right? So what the explanation of Torricellian theory was, the atmospheric pressure is applicable on the open side of this mercury, right? I'll draw this diagram again. This is our beaker. This beaker is filled with mercury, right? Now this is our tube where 76 centimeter of mercury is there. So the theory states that these sides or this open layer of mercury on which atmospheric pressure is directly applicable, they can hold up only up to 76 centimeter of mercury, and this is what the value of atmospheric pressure must be. The atmospheric pressure is measured to be that pressure which can hold 76 centimeter of mercury in its column. So according to that theory, if I use P is equal to H rho G, height of mercury column is 76 centimeter, that is 0.76 meter. Density, mercury's density is 13.6 into 10 raised to power 3 kg per meter cube multiplied by, this is 0.76, multiplied by 9.8, or acceleration due to gravity, which is 9.8 meter per second square. This value gives us 1.013 into 10 raised to power 5 pascals. So this value is called 1 atmospheric pressure, which is 1 point, or simply 1 into 10 raised to power 5 pascals. Now, very important thing is, if this is the value of 1 atmospheric pressure, okay, we'll just take the gist of the whole experiment. A mercury beaker was taken in which a meter filled tube was poured, or meter tube